Hey everybody, this is Larry. This is me going over Q4 of the bi-weekly contest 96. Check if point is reachable. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this poem. And also, happy Chinese New Year, happy Lunar New Year if you're celebrating. And also, yeah, hit all the like button. Give me a red envelope if you're doing well. But yeah. So this poem, check if point is reachable. This one, to be honest, it took me about 14 minutes or something like this, or 13 minutes. I don't know how to solve this one. I mean, or rather, I did obviously solve it, but I don't really have a proof about this very well. I kind of, and you could watch, you could fast forward later on to the portion where I did this live, and I just kind of, I have a notebook, to be honest. I don't know if you could see it. I mean, it doesn't really matter. There's no detail on it. But I was just like playing around with like almost like a manually written breadth first search to kind of see if I could see any patterns. And in fact, I actually wrote, if you watch it, the live portion, I actually even wrote out the breadth first search in code to kind of see if I could figure out some pattern. Though, to be honest, I did actually figure out the pattern kind of early. Maybe not that early, but I kind of figured out a little bit early, but I just couldn't prove it. So then I wrote a breadth first search to kind of see if I find any counter examples to my ideas. And then once that happened, then I kind of just YOLO'd, and then and then it got AC. But I'm not gonna lie, I don't know how to do this one 100% proof. I kind of proved by AC and didn't really do a mathematical proof, and that's what this poem really is a bit. It's a bit of number theory with respect to GCD and stuff like that. And so for me anyway, that's always one of my weak points. So my apologies if you're not gonna get that much from this video, but I would say there is one thing that I did think about for a second. Spoiler alert, was that you could always, so you can always reach every number when one of the numbers power of 2. So that's what I thought first, because basically going from 1 1, you can basically double, get to any power of 2 from like 1 2 1 4 1 8 ... right, to like 1 to a billion, and then just subtract 1 from each from the second number, and then eventually they'll all be, you'll reach every number. And then I kind of manually also just did it for 2s, and but then 3 was not good, right? Because and you could kind of see that for any power of, with one number is the power of 2, then any number is good for the other one, because for the same logic of 1 to, like, I don't know, some random number, you can just go to 2 and then that number, 4 and that number, ... right? And then from that, my logic was that if I don't know what my logic is after that. I think that was all my logic now that I think about it, to be honest. And I didn't know how to proceed. So that's why I eventually kind of wrote the breadth first search and kind of explored a little bit. And this is kind of what I have at the end. Basically, if, like I said, if one of the numbers is power of 2, then we're good. Or if the GCD is power of 2, then it's also good. The idea behind that is that I noticed that, and I don't know how to quite prove it, but I knew that 3 3 5 5, basically XX is not reachable if X is not power of 2. So I kind of, and that's what I wrote the breadth first search to find. And then kind of based on that, because that's not reachable, then that 2 times X is not reachable. Yeah. And then all these other things like 2 times X is not reachable, maybe. Or I think that's true. As long as X is not a power 2, right? And then, and then 4 times X, 2 times X, it is not reachable. And then, and then the thing is that you can subtract each from each other, right? That's the other 2 operation. And of course, you can always flip XY, so that's why I didn't really, without loss of generality, I kind of treat it in one direction. But yeah, and then you could kind of subtract them from each other and so forth. So then here you could, maybe you had this instead, and then now you get 3 times x. And so therefore, that's the kind of logic that I had. And by that logic, then that means that if the GCD is x, where x is not a power of 2, because that's how, because by definition, if you can't do all these other operations of adding and plussing, the GCD is going to be x, right? So if the GCD is not a power of 2, then it is not reachable. So that's basically the logic that I kind of went with. And like I said, I did the breadth first search to kind of draw a better visualization and kind of see if I could find any counter examples and so forth. And that's basically how I came up with it. It may not be the right lesson to be learning from this, but not that it's not the right lesson, but it's not the perfect lesson. But this is something that I talk about in my Discord a lot, which is that one is grind it out, and second, you don't have to have the reference solution. I mean, this may not even be the cleanest solution. I mean, I figured out it very quickly. So, but as long as you have a solution that's workable and kind of whatever, keep fighting, keep YOLOing, if you will, and yeah, give it a shot. But that's basically the idea that I kind of was playing around with, and I kind of did a hybrid proof, if you will. It's not a proof, but proof by Larry can't find a counter example. But I mean, I think afterwards, I kind of proved to myself a little bit more. So now I'm a little bit more convinced. But at the time, to be honest, I wasn't that certain, and I was just like my fingers crossed. And you can actually see the first version of this code that I have. This is what I have now, but I actually had something that is a similar logic, but not quite that. Which is that. I keep on subtracting the smaller one from the bigger one. This is essentially GCD, which is why this is GCD, except for without the mod instead. I don't know why I did it this way, but that's why I kind of resubmitted. I was like, oh, this is just GCD, and this is something that you learn from experience as well. GCD is greatest common denominator. I don't know if I didn't say that actually, did I? So if you're a little bit on the beginner side, I might, yeah. And this power of 2 thing I'm not going to explain, but for a positive number, you can imagine that all powers of 2 looks this way. So this number minus 1 is going to look like this, and then if you add it together, it's going to be 0. It's just a very lazy shortcut for me. But yeah, and I did do that live during the contest. But yeah, that's pretty much what I have. You could watch me grind it out during the contest next. Like I said, sometimes you're not going to be fast, but you can at least get it right. So yeah, I'll see you soon. Happy Chinese New Year. Hit the like button, and you could watch me solve it live during the contest now. I knew that if statement, but then I forgot to write it. That's kind of sad, actually. Okay. People really know that this is some GCD thing, but I don't know. You kind of do it backwards, maybe. 10 to the 9. If I didn't get that 5-minute penalty, I think I put in a good price, but unfortunately I did though. So this is 4-3, maybe. So this is some binary number thing. Does one of the number have to be a binary number? I think. I mean, it doesn't have to be a minimal path, so as long as we can get there. People have already gotten it though, so I feel like that's great. What does a first search look like? So so 1 2 has to be true, and then it just becomes either 1 1 or 1 4 or 2 2, and then 1 8. It becomes either 2 0, which is ridiculous, and then 2 4 without loss of generality, and then this also deletes to 2 2, but also 1 3. So okay, so from this we know that all the ones are possible. 1x is all possible. It's because you can keep on subtracting them from 1 and then doubling. Okay, and then now, so that means that, so in theory you could get to 1 9 and then and I get to 15 9. I don't know. How do people get it so quickly? He was just smart, I guess. Good at maths. Everyone got to K00. Wow, that's actually great. But I don't get the Q4 though, so that's a little bit sad. Okay, so all the ones are right. What about 2s? Can you get to 2 3? Yeah, because you can get to 1 3 and then 2 3 and 2 4 and get 2 5. Yes. So all the powers of 2s and then any number is possible. About 3. Say 3 3. Can we get to 3 3? Do I want to YOLO on it? Can I get to 3 3? You get to 1 3 and then 2 3. And then once you have 2 3, then you either have 4 3 and then, but then you cannot get to 6 3. Get 8 3 or 3 8, and then 5 3. So 5 is right. Oh, good. So one of them is a power of 2. That's good. If they add to a power of 2, that's also good, but that's not sufficient. So we have 1 3, we have 2 3, we have 4 3 in 2 different ways, and then 7 3. That's good. Then why not? And even 5 3 is good. I don't know how anymore. Oh yeah. But not 6 3. Because 3 3 is not possible, so it's not 6 3 is not possible either. How did I prove that 3 3 is not possible though? 6 9. And goes to 6 3, and 6 3 is not possible, but know this one. A lot of people got in this one though, so maybe it's a known-ish problem, just not to me. I mean, if it's a power of 2, then it's right. But then 3, 3. Well, 5, 5. You get the 1, 5 for sure. You get the 4, 5. 8 is good. What about 9, 9? 9, 9. Just be 1, 9. Sure, 2, 8. I don't know if I know this one. I'm just being lazy. I think I should have done this a while ago, which is I just figure it out a little bit. I don't know how to do this one yet. I mean, I have some guesses, but I feel like that's just, I have no proofs. Okay. I still don't know this one, to be honest. So then now I'm just kind of see. Ooh, almost click on submit. That would have been yikes. Unknown error. Thank you, sir. 7 sign it. So okay, so all the it seems like only powers of 2 of II is in it. So that means that okay. Yeah, just give me one. So wait, I just want to see the force for now. 3, 3, okay. The 19 one is a little bit actually not great, because I actually was hoping that I saw a pattern, but then the 19. Wait, but that just might mean that I didn't do enough though. So let's try it again. Okay, so the 19 is out. So then Fine. I have an idea, but I don't know if this is right, so let's play around with it. Let's see. What are we doing? Otherwise, okay, and now something like that. I don't know if it's true. There may be a case where this is not good, but I'm gonna just YOLO submit it. I kind of thought about that earlier on, but I just couldn't prove it, to be honest. It's kind of a silly problem, but a lot of people beat me on this one. But also the 5-minute penalty hurts. That one was a silly one. I don't know how to prove this one to Q4, to be honest. I don't know how people got so quickly. Maybe there's something I didn't know about. But I mean, you saw how I did it, and I probably should have done that a little bit earlier. And I knew this part was true early. The other part I wasn't able to prove, to be honest, and it might still not be right. This is basically GCD, by the way, kind of. So it's not. So it looks kind of funky, but maybe not really. If the GCD is greater than because 12 and 18 is 36, and if it's a power of 2, I don't know. Maybe something like if I don't know if that works. I know I didn't think of the rest of the code, but I'm going to YOLO submit this one just for fun. Because who cares, right? I couldn't prove this though, that's why I didn't do it. But it's, I don't know if I like this farm, to be honest. Obviously, you can make this into one line, but I just didn't want to do it. Right. Oops. I'm just submitting for no reason. But that's, I guess that's why people got it so quickly. People are very good. Yeah, hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's contest, this problem, and everything in between. Yeah, stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.